Beginning with chapter volcanoes, I'm pretty sure you've seen them, you've heard about them. Let's study about them in detail now. Let's see what we are going to cover in this chapter. What is your syllabus? The syllabus has five main answers under the volcano chapter, meaning three types of volcanoes: active, dormant, and extinct. Effects of volcanoes which are constructive, positive, and the destructive effects of volcanoes which are negative, and the important volcanic zones where the volcanoes are found across the world. In this chapter, you need to know very important examples, different volcano zones name, different names of volcanoes, and the different landforms the volcano forms with examples. And obviously, a picture study can come for your school exams from this chapter, which we will be covering. So your chapter has five main answers. Let's move to the first one. Going to the first answer, meaning of a volcano. What's the question? What is a volcano? And give an example. A volcano is a vent in the Earth's crust from which fiery hot magma erupts from the interiors of the Earth. It is a vent in the Earth's crust. It is an opening in the Earth's crust from which fiery hot magma erupts from the interiors of the Earth. Two simple examples of a volcano: Mount Vesuvius and Mount Fuji. Moving to the second answer, causes of volcano. You have three causes of volcano in your syllabus: heat and pressure, plate tectonics, magma chamber, which are explained on the next page, which we will be doing in detail. Can ask you all three or any one in detail also. So we will be covering all of them. They are from question number 2 to 5. Let's see the first cause of volcanic eruptions: heat and pressure. The question is, explain how heat and pressure inside the earth can cause a volcanic eruption. You have three causes in your syllabus. This is the first one. What does the matter say? Heat and pressure inside the earth. Temperature and pressure both increase from the surface as you go towards the center of the earth. Heat and pressure both will increase as you go from the surface towards the center of the earth. So revising from the top, what are they saying? They are saying temperature and pressure, that is heat and pressure, will increase as you go towards the center of the earth. Pressure keeps on increasing, needs a way to come out, but rocks are bad conductors of heat, so heat and pressure cannot escape from the earth. Instead, this pressure continues to be building up. Now what happens? Pressure is building up, pressure is building up, pressure is building up. The pressure forces the heat to find an escape route, which comes out through fissures and cracks in the rocks. These are fissures and cracks in the rocks. It is just like your cooker where the pressure is building up and it needs to find a way out. Same way here, heat and pressure is building up. It needs to find a way out, and the escape route comes through cracks in the rocks or fissures in the rocks. Moving to your second cause of volcanic eruption as per your syllabus, out of the third one, explain how plate tectonics can cause a volcanic eruption. This question comes for 2 marks. Let's see the answer. Plate tectonics. Most volcanic zones or most volcanic eruptions take place near plate tectonics. The Earth's crust is made up of, very important, a series of movable plates. So inside the Earth, we have a series of movable plates. You have some images here. These are a series of movable plates. The Earth is divided into, below the Earth, there are a series of movable plates. It says when these plates slide past each other or collide against each other, due to intense heat which is already inside the Earth's core, there are edges. These edges will produce faults along the line of weakness. These edges will produce faults. Faults are also known as cracks. These edges will produce cracks along the line of weakness. Here is an example. Here there will be a crack. due to sliding past each other or colliding of the two movable plates because there is intense heat already inside the earth. What does point number 2 say? It is along these plate boundaries that the crust is weakened and through which the hot magma gushes out. So due to colliding, sliding past each other, there was a fault which was created. It produced faults, it produced cracks, faults and cracks, same thing. Along which the crust is weakened, there is an opening in the crust which through which hot magma gushes out, leading to a volcanic eruption. Very important statement in the final line. The same forces causes earthquakes also cause volcanic eruptions. So the factors leading to earthquakes and volcanic eruptions are exactly same, which earthquakes will come in your next chapter. Volcanoes and earthquake causes are exactly same. Moving to the third and final cause of volcanic eruptions, magma chamber. Explain how magma chamber causes volcanic eruptions, or a very important give reason here. Volcanic eruptions are found along plate boundaries, give reasons. Let's see what does the answer say. Answer says the molten material, which is still under the Earth's crust, melts weak rocks and creates a huge chamber for itself. Now, this molten material, which is inside the Earth's crust, is hot. There is a lot of heat. There is a lot of pressure. So it melts the weak rocks and creates an empty space for itself. This chamber which is created, fresh magma continues to pour inside the chamber. Since magma contains silicate material, gases, and water vapor, the pressure always acts vertically upwards. Here is an example. Here is a photo of the magma chamber, the hollow magma chamber where fresh magma continues to pour inside. And since this magma has silicate material, gases, and water vapor, this will always act vertically upwards here. And once it finds a route, once it finds an escape route, it arises to the surface. And this is why volcanoes are also found along plate boundaries. Revising quickly, once again, the molten material which is inside the Earth's crust makes the Earth's crust melt. It makes the weak rocks melt, creating a magma chamber for itself. Magma, fresh magma continues to pour inside. This fresh magma contains silicate material, gas, water vapor. Hence, the pressure will always go vertically upwards. And finally, once a route is found, once an escape route is found, this magma will erupt, and this is why volcanoes are also found along plate boundaries. Moving to the third part, after meaning, causes, here we see products of a volcano. This is from question number 6 to 10. Here you will be covering magma chamber, products which are erupted by a volcano, that is steam, gases, and solid matter as well. And one important question, difference between magma and lava. Moving to products of a volcano, we will be covering 3 questions on this page. Question number 6. What is the magma chamber of a volcano? A magma chamber may be defined as a partially or totally molten body located at the Earth's crust and which is capable of supplying magma to volcanic eruptions. Here is the image. Here you can see this is the magma chamber. What are the keywords? It is partially or totally molten body. It is located at the Earth's crust. Here it is. And it is capable of supplying magma to the volcanic eruptions. From the magma chamber, we have a volcanic eruption which comes out. in your magma chamber. Move to question number 7, very simple. Explain the products erupted by a volcano. The products which are erupted during a volcano is steam, gas, molten rock, dust, ash, other liquid and solid matter. Question number 8, magma and lava. Very important question. What is the difference between magma and lava? Very important, short question. What does it say? It says the molten rock material, when it is inside the earth, is known as magma. When the same molten rock material reaches the surface of the earth, it is known as lava. It consists of many materials and gases, as you've done in question number 7 also. Revising once again, when the molten rock material is inside the earth's crust, is called as magma. And when the same molten rock material erupts and comes out on the surface of the earth, which you and I can see, is called as lava. And lava contains many minerals and gases. Here is the answer you've done. For many minerals and gases which are erupted during a volcanic eruption. Into question number 9, explain steam and other gases which are released as products of a volcano or products of volcanic eruption. Steam is the most abundant gas that comes out of a volcano. When steam is ejected in huge quantities, it forms clouds in the atmosphere, resulting in rainfall. So we can also say that sometimes after volcanic eruptions, there is rainfall also. Why? Because steam is the most abundant gas which comes out from a volcano. This steam goes and forms clouds, and which eventually results in rainfall. Other gases which are ejected by volcanoes include hydrogen sulfide, sulfur dioxide, carbon dioxide, and hydrogen. These are all the other gases which are also ejected during a volcanic eruption, but steam is the most abundant gas. Moving to solid matter, which is given out during a volcanic eruption, 4 of them. Number 1, pyroclasts. Here's an image of pyroclasts. They are solid fragments. The solid fragments are rock pieces known as pyroclasts. The solid fragments are rock pieces known as pyroclasts. Second one, dust. The fine dust particles or the fine particles are called as dust. The dust particles goes on increasing in size. And number 3, lapilli. They are small stone-sized particles, SSS, small stone-sized particles called as lapilli, which come out also during a volcanic eruption. And finally, bombs. Volcanic eruptions known as bombs eject more materials. So 4 solid matters, pyroclasts, dust, lapilli, and bombs, which are ejected as a part of volcanic eruptions. Moving to structure of a volcano. You have just one question, question number 11. Structure of a volcano can also come as a picture study question, which we will be covering. Let's see the question number 11, structure of a volcano. What are the different parts of a volcano? It says the lava flows out through an opening in the Earth's crust, called as the vent. The opening is usually circular pipe. So where the lava comes out, from where the lava comes out, that's what we call as the vent. Here you have an image. Usually the vents are circular pipe or circular in nature. There can be more than one opening. Subsidiary vents are formed due to repeated eruptions. Here is an example of subsidiary vent. Subsidiary vents can be formed due to repeated eruptions. Second part of a volcano is the volcanic cone after the vent. The erupted material, being hot, collects around the vent and begins to cool and gradually solidify. So this lava which has come out
will get collected here, and it will begin to cool and solidify eventually. The accumulation of the material around the vent, the accumulation of material around the vent gives the volcano its typical cone-like structure. So the second one is the cone-like structure. That is, revising once again, volcanic cone, the erupted material when comes out, here is the erupted material which is coming out, it will cool and gradually solidify. Will solidify to form rocks. This accumulation material around the vent gives it a cone-like shape. This is known as the volcanic cone. So these are the two structures of a volcano. Vent, which are usually circular pipe, subsidiary vents can be formed, and volcanic cone, they are cone-like structures. Moving to the next answer, types of volcanoes. In this, you will be studying three types of volcanoes, and you'll be studying about Mount Vesuvius. Two questions, question number 12 and 13. Let's see the three types of volcanoes: active, dormant, and extinct. They can ask you meaning and example of each, or they can ask you a difference between any two: active, dormant, and extinct, with examples. I've given it to you in table form. You can write it as meaning and example if they ask you one. If they ask you difference, you will have to write it in columns. Let's see active volcanoes. What is the meaning? The name itself says these volcanoes are active in nature and can erupt anytime. These are volcanoes which are presently active, which are presently in active state and have erupted in the recent past. So they have erupted in the recent past and they are currently in the active state. There are at present 500 known active volcanoes, about which 20 of these volcanoes can erupt at any given point of time. A few of these volcanoes are also known in the state of permanent eruption. So revising, they are presently in active state. They have erupted in the recent past. There are at present 500 known active volcanoes, out of which these 20 volcanoes may erupt at any given point of time. They are also known as volcanoes which are in the state of permanent eruption. Examples of active volcanoes are Mount Stromboli, here is a photo, Mount Etna in Italy, Stromboli and Etna in Italy, Pinatubo in Philippines, and Mauna Loa in Hawaii. Second type of volcanoes, dormant volcanoes. These volcanoes have not erupted in recent historical period. They are also known as sleeping volcanoes, but they may become active at any given point of time. Revising keywords, they have not erupted in recent historical period. Sleeping volcanoes, but they may shift categories from dormant to active at any given point of time. Examples of dormant volcanoes, Mount Kilimanjaro in Africa, and many other volcanoes in Philippines and Japan are examples of dormant volcano. Here is a photo of Mount Kilimanjaro. And final category of types of volcanoes are extinct volcanoes. These are those volcanoes which have not erupted in present geological period and are not likely to become active ever again. Once more, they have not erupted in present geological period and are not likely to become active again. For example, Mount Aconcagua in South America. Here is a photo of Mount Aconcagua, Mount Kenya in Africa, and so on. Moving to question number 13, a very, very important answer. This question is loved by many school teachers. It's a very important answer. Make sure you do this and go. It's a short answer. What is it? Mount Vesuvius, though regarded as active. Mount Vesuvius, you have a photo, though regarded as active, is actually rated in dormant. So we regard it as active, but it is rated as dormant. Give reasons. A very important answer, a sure short answer. Question paper is incomplete without this question. What does it say? Mount Vesuvius, though regarded as active, is actually a dormant volcano because there has been no major eruption since 1944. A single line important. There has been no major eruption since 1944. Moving to the next answer, effects of volcanoes. Effects of volcanoes in your syllabus is divided into constructive and destructive effects. They are together from question number 14 to 22. We'll be doing 10 constructive effects and 5 destructive effects. Let's see constructive effects, question 14 to 21. There are 10 of them. Moving to constructive effects, question number 14. Explain briefly the landforms which are created by volcanic eruptions. Explain briefly the landforms which are created by volcanic eruptions on the surface of the earth and give examples of each. It can also be known as what are extrusive landforms. Once more, it can also be known as extrusive landforms. You've done this before in the earlier parts of the syllabus. Extrusive, as the name suggests, extrusive is outside, exterior. So what are extrusive landforms? The answer says numerous types of landforms are created due to cooling and solidification of magma. Rising due to cooling and solidification of magma below the Earth's surface and lava on the Earth's surface. So a number of landforms are created when magma and lava cools and solidifies. It makes rocks. Which are these rocks? You have done them in the previous chapter. Igneous rocks. These landforms created on the Earth's surface are called as extrusive landforms because they are on the exteriors. You can see them. For example, volcanic plateaus. Here is an example photo. Volcanic mountains and volcanic plains. Keywords there: cooling and solidifying of magma below the surface of the Earth and lava above the surface of the Earth forms extrusive landforms. 15th question, explain volcanic plateaus as a constructive effect of volcanoes with the help of examples. So here we are saying volcanic plateaus or volcanic mountains or volcanic plains are all constructive effects. They are good and they have positive effects. What does it say? Let's see. Volcanic plateaus, they are derived from lava which flows from volcanic eruptions. As the name suggests, these plateaus are made because of volcanic eruptions. Examples: the plateau of peninsular India, that is the Deccan Plateau, the South Indian Plateau. Very important, it is an example from India, you have to know this. Especially the northwestern Deccan is an example of the lava plateau. Another examples of these plateaus are here: South African, Colombian, and Ethiopian. Here you have an image of the Colombian plateau. So these plateaus are formed because of volcanic eruptions. One key example is the plateau of peninsular India, which is from India. Other examples: South African, Colombian, and Ethiopian. Question number 16, explain volcanic mountains as a constructive effect of volcanic eruptions with the help of examples. Or this one, once again, a very important question. No question paper is complete without this question. Please make a note of this. Sure shot, 100%. Volcanic mountains are the most diverse. Give reasons. Volcanic mountains are the most diverse. Give reasons. Let's see the answer. These mountains, volcanic mountains, are built from materials which are ejected from fissures. When volcano comes out, then it will cool, then it will solidify and form volcanic mountains. So volcanic mountains are built from materials which are ejected from fissures in the Earth's crust. Volcanic mountains are the most diverse because here it is underlined, there is a great difference in volcanic eruptions. as well as the material which is thrown out. So each volcanic mountain may be different from each other. Why? Because there is a great difference in the volcanic eruption, as well as the material which is thrown out, as well as the shape which it may look like. There may be too much volcanic eruption on one side. There may be equal distribution of volcanic eruptions. It may look like this, and then there may be too much of volcanic eruptions on one side rather than happening on both sides. As a result, volcanic mountains are very diverse because there is a great difference in volcanic eruption, that is quantity, as well as the materials they throw out, as well as the shape which can be formed. Example, volcanic mountains like Mauna Loa in Hawaii. Mauna Loa in Hawaii rise 9 kilometers from the ocean floor. Volcanic mountains which are common in the circum-Pacific belt include Mount Fuji, Japan. Photo is here. Mount Mayon, Philippines. Mount Merapi in Sumatra. Mount Agong in Bali, and Cotopaxi in Ecuador. Here you have a photo of Cotopaxi, Ecuador. So what are the examples of volcanic mountains? And they are very diverse. We'll see the examples. Mauna Loa, Fuji, Mayon, Merapi, Agung, and Cotopaxi. Moving to question number 17, explain volcanic plains as a constructive effect of volcanoes. With the help of examples, what are volcanic plains? Volcanic plains are vast and smooth formed by extensive volcanic flooding from volcanic centers. When this volcano comes out and spreads through a long area over kilometers and kilometers, and plains are, as we know, vast and smooth. So when a plain is formed because of volcanic eruption, when the volcanic eruption, the volcano spreads very, very, very far away, vast and smooth, extensive volcanic flooding and volcanic centers. That is, after some time, obviously, as we know, the volcano will cool and solidify into rock. And once that happens, these volcanic plains are formed, which are vast and smooth. Example of volcanic plains are the Western Victorian plains in Victoria, Australia. Here you have an image. Western Victorian plains in Australia are the finest examples of volcanic plains. These plains were formed by volcanoes over the last 6 million years. So it took a lot of time. It takes a lot of time to volcanic plains to be formed, with the most recent eruption happening around 7,200 years ago. The most recent, can you see the word of using recent eruption? The geological age. 7,200 years as per geological age is recent, which happened in Mount Napier. And finally, over 400 volcanic sites have been found in this region. Moving to constructive effect, next one, question number 18. A very important answer, sure shot. You have to know this. This comes in majority of the question paper, and as I said, sure shot, no question paper is complete without Caldera Lake. What is Caldera Lake and how is it formed? What does it say? During repeated eruptions, the summits of a volcano may be blown up. Due to repeated eruptions, here you have an image. It is a 4-step process. During repeated eruptions, the summit of a volcano is blown up. It's written here, the caldera collapses. The summit of the volcano may be blown up. Here is the example, the caldera collapses. In its place, a large depression is formed. A large depression is formed called as the caldera. These are generally formed when magma chamber is no longer able to emit significant amount of magma, and as a result, and it results in the collapse of the cone either partially or wholly or partly or wholly. Revising once again, during repeated eruptions, The summit of a volcano may be blown up. In its place, a large depression is formed called as the caldera. They are generally formed when magma chamber is no longer able to emit sufficient magma, and this results in the collapse of a cone either partially or wholly. When the chamber cannot emit more magma, it results in the collapse of the entire cone partially or wholly, and this is called as the caldera. This depression is eventually filled with water to form a lake. This depression is eventually filled with water to form a lake, which is called as the caldera lake. Very important example of caldera. Crater Lake in USA is an example of the caldera lake. Here is an example of the caldera, that is the Crater Lake in USA is an example of the caldera as per your syllabus. There are more caldera lakes around the world. Crater Lake in USA is one example which you have. It is about 10 kilometers wide and the deepest lake in USA. A very important question, caldera, example of the caldera as per your syllabus, crater, and how is the caldera formed. No question paper is complete without this question. It's a short answer. Moving to the next one, hot springs as a constructive effect with examples. Again, an important give reason here. Short. You need to know this. Hot springs have medicinal hot springs have medicinal properties to cure skin diseases. Give reason. Let's see what are hot springs. The movement of magma in the interior of the earth heats up the underground water, particularly around the magma chamber. So there is magma under the ground. There is underground water. The magma will heat the underground water, especially that water which is near the magma chamber. Now what happens? When the water turns into steam, that is when magma and water come in close contact with each other, this water turns into steam and it gushes up. Revising once again, the movement of magma in the interior of the earth heats up the underground water, particularly around the magma chamber. When the water comes in contact with the magma or comes close to the magma, this water turns into steam and gushes up. Hot springs are also known as thermal springs because they contain many dissolved minerals. Since hot springs are rich source of sulfur, they can also be considered good for health, especially for curing skin diseases. As the question says, hot springs have medicinal properties to cure skin diseases. Give reasons. So here it is. Hot springs are also known as thermal springs. They contain many dissolved minerals. Since hot springs are rich source of sulfur, they can be considered good for health, especially for curing skin diseases. Examples, sulfur hot springs is in India, that is in Manikaran in Kulu. Here is an example, Manikaran in Kulu. That is in the Kulu Valley of Himachal Pradesh, is a great tourist attraction spot as well. Next one, similar to hot springs, is geysers. Explain the term geysers with the help of an example. A geyser is a fountain of hot water and steam that escapes when underground water comes in contact with hot volcanic rocks. When the underground water, very similar to hot springs, there was no contact. Here there is contact. When underground water comes in contact with hot volcanic rocks, a geyser is coming out, that is a fountain of hot water and steam. For example, Old Faithful Geyser in Yellowstone National Park in USA. Old Faithful Geyser in Yellowstone National Park in USA. Here are these examples of the Old Faithful Geyser. During an eruption, Water temperatures at the vent are nearly measured at 95.6 degrees. So hot springs and geysers are to some extent similar, but they have a difference. What is it? That the temperatures of geysers go up to 95.6 near the vent. Hot springs have medicinal property. There was example as per your syllabus, previous one, Kulu Valley, Himachal Pradesh, Manikaran. Here they have given you Old Faithful Geyser that is in Yellowstone National Park, USA. Geysers are very, very hot as compared to hot springs. Hot springs you can bathe and they also have medicinal properties. As you know, there is more content of sulfur used to cure skin diseases. Here, geysers are very hot, that is 95.6 temperatures near the vent. Hence, bathing is not possible. So, in case they ask you a difference between geyser and hot spring, you have the meaning as well as the example. Some other constructive effects of volcanoes. Good for agriculture. The lava and ash deposited during eruptions break down to provide valuable nutrients for the soil and thus create fertile soil, which is good for agriculture. That is, the volcanic eruption gives you valuable nutrients for the soil, which creates fertile soil and is good for agriculture. Second one, geothermal energy. The places that have high levels of heat due to volcanic activity inside the earth have higher potential for generating geothermal energy. Here is a photo of geothermal power plants. And finally, lastly, attracts tourism. The dramatic scenery created by volcanic eruptions attracts tourists. This also brings income to those areas. It's a source of revenue generation. This completes all your constructive effects of volcanic eruptions. Let's see destructive effects. That's question number 22. We'll be doing 5 destructive effects which are there in your syllabus. Moving to destructive effects of volcanic eruptions. Here, question number 2, explain any 3. As per your syllabus, you have 5 destructive effects. We will be doing all 5 of them. Let's see the first one. It destroys life and property. Now you're going to show negative sides of volcanic eruptions. Obviously, volcanoes are not good. Number 1, you're saying it destroys life and property. When the volcanic eruptions erupt, they destroy life and property. The hot lava together with ash and dust destroy not only human beings, they destroy not only human beings but also animals as well as plant life. Going to the second destructive effect out of 5, agricultural fields are covered with layers of volcanic ash. Here is a photo, agricultural fields. Here is a photo of vegetation getting destroyed due to volcanoes. Agricultural fields are covered with layers of volcanic ash as the dust makes them unsuitable for cultivation. And finally, floods and landslides. Huge clouds are formed after eruptions of volcanoes, causing heavy rains, which eventually results in floods and landslides as well. We had said this before also. Volcanoes, following volcanoes, there is rainfall. If the rainfall is too high, then it results in floods and landslides as well. Last 2 negative effects, emit poisonous gases. Volcanoes emit poisonous gases which pollute the environment and cause health problems. And finally, last destructive effects, volcanoes cause tsunami waves. Here is an image of volcanoes causing tsunami waves. Explosive volcanoes in ocean islands are followed by high tsunami waves. They flood the area and destroy property, people, animal, and crops. Tsunamis destroy property, people, animal, and crops, and these tsunami waves are caused due to volcanic eruptions, which are close to ocean islands. This completes all your 5 destructive effects of volcanic eruptions. Here we are showing negative sides of volcanic eruptions. Moving to the last answer of your chapter, important volcanic zones. Question number 23, you learn about two important volcanic zones, that is the Circum-Pacific Belt and Mid-World Mountain Belt. Let's see what are they speaking about and the examples. That is, here, describe the world distribution of volcanoes or explain the Circum-Pacific Belt or Mid-World Mountain Belt. Let's see what is the Circum-Pacific Belt. Here you have an image. The volcanoes occur near the volcanoes occur near earthquake belts around the Young Fold Mountains. The Circum-Pacific Belt is also called as the Pacific Ring of Fire. Very important. Pacific Ring of Fire. What is the Pacific Ring of Fire? Why is it so called? So the Circum-Pacific Belt is also called as the Pacific Ring of Fire because over 80% of the total active volcanoes are concentrated in this region. So world ka 80% of active volcanoes are found in this region, that is the Pacific Ring of Fire. Once again, 80% of the total active volcanoes of the world are found in this region. Among these include 40 active volcanoes in the Andes, 100 in the Philippines, 70 in Indonesia, and 40 in Japan. This entire region is called as the Pacific Ring of Fire, where active volcanoes are found. How many of them? Revising once again, 80% of total active volcanoes in the world are found in this region. Moving to the second belt, that is the Mid-World Mountain Belt. Explain the Mid-World Mountain Belt as a volcanic zone of the world. Mount Vesuvius, Mount Etna, Stromboli are famous active volcanoes which are in the Mid-World Mountain Belt. These are located in the Mid-World Mountain Belt. Here you have an example of the Mid-World Mountain Belt. Example, the only active volcano in India is the Andaman and Nicobar Islands. I'll repeat it once more. Here is the question. Name an active volcano in India. So the only active volcano in India is the Andaman and Nicobar Islands, which is also located in the Mid-World Mountain Belt. Finally, the Hawaiian Islands, Canary Islands, Mount Kenya are other examples which are located in the Mid-World Mountain Belt. So 80% of active volcanoes were in the Circum-Pacific Belt, and the remaining, which are smaller, is the Mid-World Mountain Belt. Example in India is very important. Only active volcano in India is the Andaman and Nicobar Islands. You have other examples in the Mid-World Mountain Belt also. Vesuvius, Etna, Stromboli, Hawaiian Islands, Canary Islands, Mount Kenya are all in the Mid-World Mountain Belt located. This completes the important volcanic zones of the world answer, as well as this brings an end to your chapter.